Determination of intensity of sound. Rayleigh disk method. The Rayleigh disk is an absolute device for the measurement of sound intensity. It is based upon the famous principle of hydrodynamics that when a flat disk is suspended in a direct or alternating fluid stream, it is acted upon by a couple tending to set the plane at right angles to the direction of flow of the stream. Figure shows the lines of flow of the fluid passing a flat disk. The lines are most separated at points A and B, and velocity here is 0, and the maximum and the pressure is maximum according to the Bernoulli's theorem. Hence, a clockwise couple acts on the disk, tending to set it perpendicular to the lines of flow. In case of circular disk of radius A, suspended in a fluid of density rho, the couple is given by tau or couple equals to 4 by 3 into rho into AQ average U square into sine 2 theta. This is equation 1. Here it is also tau or couple. Here A is the radius of disk and rho is the density of fluid, and couple is maximum when theta equal to 45 degree. Here average U square bar, it is this value, is the velocity of the stream, and theta is the angle between the normal to the disk and the direction of flow of the fluid. In the case of alternating stream, U square bar is the root mean square velocity. This is root mean square velocity. The couple is maximum when theta equal to 45 degree. Now let's describe it. The Rayleigh disks shown in figure consist the Rayleigh disk. This is the Rayleigh disk shown in Rayleigh disk method shown in figure consists of a brass pipe of length 3 by 4 lambda, where lambda is the wavelength of the sound which is to be compared. The pipe is open at one end and closed with a glass plate at other end. At an antinode distance lambda by 4 from the closed end, a light circular mirror disc D is hung by a fine quartz fiber. The mirror acts as a disc. The plane of the mirror is adjusted at an angle of 45 degree with the axis of the tube when there is no twist in the fiber. Light from lamp is made to fall on disk D, mirror disk, which reflects it on to a scale through a glass window. This is glass window. When a sounding source is placed near the open end of the tube, the air in the pipe is set into vibration, and therefore a coupled due to airflow acts upon the disc, which turns until brought to equilibrium by the couple due to the torsional reaction in the suspension wire. Now if I with the angular twist and see the torsional copper per unit twist, then the total torsional couple will be C into phi, and at equilibrium this will be equal to the turning couple tau, and therefore C phi equals to 4 by 3 pi rho into aq u square bar into sine 2 theta. This is equation 2. But here theta equal to 45 degrees, so sine 2 theta equals to 1. Therefore C into phi equals to 4 by 3 rho aq u square bar, equation 2. Now the particle displacement of a medium carrying a wave is given by y equal to a sine 2 pi by lambda into vt minus x. Where a is the amplitude of the travelling wave and v is the velocity of the wave, sound wave or propagation of wave. So the particle velocity of wave is given by u equals to dy by dt equals to differentiating this value. You get a into cos 2 pi by lambda into vt minus x into 2 pi v by lambda. So the mean square particle velocity is given by u square bar equals to 1 by t. T is the total time period, integration 0 to t u square dt, and putting the value you get 2 pi a v by lambda to the whole square 1 by t 0 to t cos square 2 pi by lambda vt minus x into dt, or equals to a square of under bracket 2 pi a v by lambda into 1 by 2. But you know v by lambda equal to n, which is the frequency of the wave. So we have u square bar, that is root mean square velocity, equals to 2 pi a square n square. But we know that intensity of the wave is given by 2 pi a square n square v rho. Hence using this value in this imply I equals to average of u square bar into v into rho, or u square bar equals to I by v into rho. Thus u square bar proportional to I. This is equation 3. So from equation 2 and 3, equation 2 and 3, we can compare the intensity of the sound, That is, the two sounds whose intensities are to be compared are made to produce vibrations in the pipe one by one, or